Hello, my name is Izzuddin Osman, and in this tutorial, I'm going to teach you how to design a floor plan using AutoCAD. So basically, we are going to design this particular floor plan according to its measurement, and we are going to convert this particular floor plan into 3D design. This is the visual which I have drawn over here. So to build this particular 3D design of this floor plan, you must first draw the 2D floor plan. So I'll change back to top view and change my visual style to 2D wireframe. So you can see this is the basic structure of the plan. So whenever you want to draw any plan, you must first specify your units. So I'm going to type units now, UNITS. Whenever you type something, the command list will be prompted over here. So I'm going to choose units and choose millimeters. You can also choose inches or centimeters, whichever units that is suitable for your work or task. So in this particular project, I'm just going to use millimeters and click OK. If you are referring to inches, you just got to make sure that your length is in either architectural mode or in engineering mode, giving you precision of feet and inches over here. So but in this project, we are more focusing on millimeters. So I'm going to change this to millimeters and select my length as in decimal. Click OK. So whenever you want to start a floor plan, you must also set your limits, which is your drawing area. So basically limits has a minimum point of 0,0, and I'll type 20,000 as in 20 meters as my maximum point. So this maximum point for my upper right corner actually depends on the object or the plan which I want to draw. So 20 meters actually covers this particular area. If you have a larger object or larger plan to draw, you can adjust this particular upper right corner maximum point. So I'll type 20,000, 20,000 as my maximum point, and I press enter. Then I'll type Z, enter, and A, enter for all to zoom everything. So this is the floor plan which we are going to draw now, and basically we are going to convert this 2D floor plan into this 3D model as shown in this visual over here. So I'm just going to change this back to top view. I'm going to change my visual style to 2D wireframe. Okay, so in this particular floor plan, you can basically start your point anywhere on this AutoCAD work area over here. So I just click line, or I can also type L, enter. I will start somewhere over here, click, and then I'll polar track this. This measurement is 5,000. Then I'll polar track to the left, and I'll type 3,000. Then I will just use my object snap track to track for this part over here. Click and click, press escape. So now because this particular room has the same size, so I will copy this particular room by typing CO, enter. Select this area of the room, choose a base point over here, click, and choose a displacement point over here. Click, press escape. Then I'll type L, enter to launch the line again. and I'll start somewhere over here. Click Polar Track. Type in the measurement of 3000 as in 3 meters. So now I'll still be using my object snap track to draw this part over here. Click and click. So and then you press escape. So whenever you want to use your object snap track setting, you must make sure that your polar track is on in your activation bar over here. So you can see now my polar track activation is on, including my object snap track and also my object snap. You can also double check by right clicking object snap settings and just make sure all of this list of your object snaps are on, including your endpoint, midpoint, center, intersection and extension, and then you click OK. So I will continue this by typing L enter, click this point, click polar track this. So I'll take measurements as in 3000 over here, and I will project this part by looking at this measurement. From here to here is basically 8000, so I'll type 8000 as its measurement. So from here to the top is around 3500, so I'll type again 3500 over here, and the balance wall over here is 2000, so I'll type in 2000, and I'll use my object snap track to get this this part over here. Click and click. Okay, this area over here, I got to measure this. You can also measure this particular object by typing DLI, enter, to initiate the dimension linear command. So you can just click this point and click this point, and you can measure up this particular object. Here you can see clearly that this object is, the measurement of this object is 3 meters or 3000 mm. So I can definitely create a reference line by typing L enter and click here, polar track this and type 3000. Okay, to get the particular line projected here. So in this case, I will try to project from this middle point over here and object snap track this. Okay, and shoot this particular wall measurement as in 3500 and join it here. You can see in this part, right, the wall has a curved edge. You can also use fillet or fillet command to actually round up the corner of this wall. So I'm going to launch the fillet command by typing F enter to launch fillet command, and I'll call the radius option by typing R enter, and I'll type the radius as in 2000 mm or 2 meters as its radius, and after that AutoCAD will actually ask us to select the respective line for us to define where the corner edge to be curved. So I'll click this line and click this line. You can see this part is curved. So I can launch back the fillet command by typing F enter and click this line, click the other line to make this one curve. So this particular part, I can select this line and just stretch it until it reaches here. So basically you have drawn the main structure of this floor plan, right? Now what you have to do is to create the wall thickness. You can also establish this by digital trace. Okay, in this case we'll be using boundary command. So you just type bo enter to launch boundary command. Okay, you can see this button over here. It shows, or it prompts us to select or pick an area for us to digital trace. So I'll click this particular button and click this area to digital trace that. Click this area to digital trace that, and click all the respective areas for us to digital trace it, and press enter. Now I'll press enter to finalize all the boundary or the digital traces created automatically by the computer. So now you are going to offset this particular area. So I'll offset it by 100 mm. So I'll type O enter, and I'll type 100 as its thickness, and I'll just click this line and I'll offset it inside. So I'll just click this line and offset it inside. You can see it will be all of the lines will be offsetted inside all together, right? So all together at once. So I'll just click this line and click inside to offset this inside. I'll click this line, this wall, or this line. So I just click inside to offset the digital trace inside. So and then I'll press escape to cancel off the command. So I'll further digital trace all together the whole floor plan by using a rectangle, just to mark the total area of this floor plan. So I just type REC, enter, and I'll click on over here, click until you reach here, and click here also, and this particular rectangle boundary, right? So I'll offset this to 200 mm. So I'll just type O enter, and I'll type in the distance of 200 mm as its thickness of the wall. So I press enter, and I'll click this line and click outside. Okay, notice that all the boundary or the digital trace, right, the lines are all joined together like this. So what you need to do right now is to exclude all of them, or ungroup all of the joint lines. So you can establish this by selecting the whole floor plan and just type X enter to exclude it. So once excluded, all the lines will be broken apart. So you can actually select on the center line, right, like this, and delete all the center lines. So basically we don't need the center line right now. So I'm clearing up all the center lines in this floor plan because we don't need it anymore. So I'll just select it like this, since the lines have an overlapping lines beneath it. So I'll select all the lines like this first and press delete key on your keyboard. Okay, now I'm gonna change this view. Okay, currently we are under top view right now, so you can actually see this. We are under top view, so I'm gonna change this to southeast isometric view by clicking this, and I'm choosing this isometric view, which is the SE isometric view, or the southeast isometric view. So I'll get a very nice visual of this perspective view. You can also easily change view over here. You can also change your visual style of your drawings by clicking here. Okay, now what are we going to do is next, right? We are going to convert this 2D floor plan into a 3D floor plan, just like what I did over here, right? Okay, it is very important for us to know that if you are planning to do some 3D modeling tasks, right, you better choose the 3D modeling workspace interface by clicking over here. So you can see currently I'm using this particular workspace, which is 3D modeling. So it gives you all the buttons you need in order for you to create 3D. Okay, so now I'm gonna change my visual style back to 2D wireframe. Okay, and I will use the press pull command to actually convert all of these lines, all of these walls into 3D. So press pull command is something like extrude command, just that press pull does the job faster compared to extrude command. So I'll click press pull command, and I will try to move my mouse and to select the area inside of the wall which I want to press pull or which I want to extrude. Okay, I will click in this area. Notice that while doing this, I'll be currently under 2D wireframe visual style. So I'm under SE isometric view, and I'm still under 2D wireframe visual style, and I'll click this particular inside the area of the wall, right? Click. Okay, you can see AutoCAD has captured the region of the wall which I want to press pull or extrude. So then the command will ask us, right, what is the height? So I'll put 3 meter or 3000 as its height and press enter. Okay, and press escape to terminate the command of the press pull command. So it can change back to conceptual. You can see the walls has been generated by using the press pull command. Press pull command does it really fast, really efficient also. Okay, you can see we have the main structure of the walls already. Okay, we are going to do something like drawing or design over here. Okay, now I'm going to show you how to create the doors. If you plan to create the doors on your floor plan, this is how you do it actually. Okay, you can also use this orbit command to orbit a little bit. You can use the free orbit and orbit this. Okay, this one I'm just clicking and dragging inside the orbit to actually navigate through my plan, right? Okay, so you can also press escape if you want to get out from the orbit. So there is a shortcut for the 3D orbit. You just have to hold on your shift key on your keyboard, click and hold on to your scroll key, and then move your mouse. Okay, So I'm actually doing this 3D orbit by using a shortcut way, which is I'm holding on my shift key, press and hold on your shift key, and click and hold on your mouse scroll, click and hold on to your mouse scroll, and move your mouse a little bit to navigate in 3D orbit mode. So okay, now I'm working. I want to try to create a cross section of the door on this wall. So if you want to do that, it is best for you to define your user coordinate system or the UCS command. Just type UCS, click on the UCS command over here, and click this point. Click this point to define your x-axis. Okay, and click this point also to define your y-axis. So now your x and y's are actually directly on the surface of the wall, so easier for you to target the surface of the wall and work directly on that surface by using the UCS command. So UCS command is more accurate than dynamic UCS. Dynamic UCS does this particular job automatically, but sometimes dynamic UCS is not that accurate. While moving your mouse, you can by mistake select the surface which you don't want to work on. So it is better for you to use UCS command rather than the dynamic UCS command. So now I'll change my visual style to 2D wireframe. Okay, and I'll just launch the polyline command, PL enter. Okay, and I'll take my mouse, put it here as my starting point, but I will not click on this point. I will extend it using the object snap track. Maybe I'll stop around 300 mm as its distance from its corner point of the wall, and then I click here and pull a track up as much as 2100, which is the height of the door, and I'll pull track this. I'll pull track that and enter the standard width of a door, which is around 900 or 3 feet. Click and click over here. You can see if you are using polyline command, right, all the lines which you have drawn are all joined together. So polyline command works better than line command because while drawing this cross section, all the lines are joined together automatically. So it's easy for us to use the press pull command to create a cutout or subtracted wall, okay, to insert the door. So you can cut out this particular wall by using the press pull command. So I just type PRESS and choose the press pull command from the list and click this area and just pull it out like this to create a cutout or the subtracted wall or the door opening. So I'll just change back my visual style to conceptual. You can see the cutout of this particular wall. It's very easy to do this by using the press pull command. So you just need to repeat, right, the steps to create all the other doors. So I'll just create another door here. Okay, I'm just repeating the steps which I've done here. So I'll just change back my visual style to 2D wireframe. Okay, and then I'll type PL enter. So I'll take my mouse and position it here, right? But I won't click it. I will not click this corner point. I'll just move my mouse. Okay, and you can see the object snap track is projecting over here. So I'm just defining the distance between the corner point of the wall and the starting point of the door. So I'll stop here and click this particular point as my start point. Polar track up and enter the height of the door. Polar track here to the right and enter the width of the door, 900 mm, or it's around 3 feet. Click over here and click over here. To create this cutout or the door opening or the subtracted wall, you can just type press pull command, type PRESS and choose press pull command in its list over here. Click. Choose the area which you want to cut out. Click and pull it out and click also. See how easy it is. Press escape to terminate that particular command. See how easy it is for us to actually subtract a particular wall by using a press pull command. So press pull command does it automatically and really fast. So I truly recommend this technique to all of the designers out there. So if you want to create the door itself, you can use a box, right? And just draw a box to represent the door, and then you can move that particular box, move it over here to create the door itself over here. You can see my UCS or the user coordinate system projections, or the orientation of my UCS is like this. So if I want to reset my X and Y's, I can just change the view to top and change back my view to SE isometric view to get the normal or the standard UCS, which is XY axis represent the base of any object, the Z axis represent the height of the object. So I'll type BOX, right, to launch the box command. So I'll just draw by using a mouse by estimation, and I can select back the box and right click my mouse, choose properties to enter the dimensions of the door. So I'll type 20 mm as its length, 900 as its width of the door, and I'll type 2100 as the height of the door. So you can even change the color of your door by using the properties option here. So I'm going to change it to green color now. So click this particular properties box to close the properties. So if you want to rotate this, you can just type RO, enter, click over here, select the box, press enter, choose any base point on the box and use your mouse to rotate. If you reach to a polar track projection like this, it means you have rotated it 90 degree. Click it again to end the rotation, and I'm gonna move this door on the subtracted wall. So I'm going to change back to wireframe. I'll type copy, better yet, I'll copy this door. I'll type CO, enter, select the box, enter, and I'll choose this particular point as my base point, click, and I will park it over here directly at the center of the door opening or the cutout, and I'll put it over here also. So I'll change back to conceptual. So you can see now the doors are parked correctly on the cutout. Okay, so I'm going to select this door again, delete it. So let's take a look again to the finished design over here. You can see some of the walls are created with frames, steel aluminum frames with glasses, and there are the main entrance door over here. So now what I'm going to do is I will try to create this particular glass wall with the steel aluminium frames and everything over here. So I'll change my UCS here so that it is respective to this wall. So I click this origin, click this direction as my X, click, and click at this corner point to set my Y-axis. So I'm going to change back to 2D wireframe visual. Okay, so basically I'm going to draw a rectangle. So I'm just I'll type REC, enter. Okay, click any point as your start point of your rectangle, and then call the dimension option of the rectangle command. Type D, enter, to call the dimension option of the rectangle command. So I'll type in the length of the rectangle as 1500, enter, and the height or the width is 3000. Click. So and then click a final click to end the particular rectangle over here. So regarding this particular wall glass, right, you can see over here is something like that. Okay, now I will offset this particular rectangle by typing O, enter, and enter 50 as my distance, and offset this inside. So I'll get the frame of that particular wall glass. Go back to 2D wireframe. Okay, so this, you can see the rectangle here is joined, right? So I'll select the rectangle over here and type X, enter, to explode it. So I'll get this piece individually broken apart. So I'll type O, enter, and type 1000, which is 1 meter, and offset this part here. So you can see 1 meter is a little bit too much. By referring to this particular design, right, this part is not to say 1 meter, but you can say it is half a meter. So I'll select this line again and delete it, and change back to wireframe. Then I type O, enter. I'll type 500, which is half a meter, 500 mm. So select this wall, select this line, select this line, and bring it down over here, and press escape. Okay, so I'll get this particular part and offset it again, right, by 50 mm. So I'll get this part, right, offset it like that. So I'll trim this part by using the trim command. So I type TR, enter twice. Okay, basically I got already the cross section of this glass wall. Okay, so how to extrude this? You can use the press pull command. So I'll type PRESS and try to select the area over here. Okay, so to accurately do this, I'll try to move this first elsewhere so that it doesn't clashes with the design, the walls which I've designed earlier. And I'll make it a point to change the UCS directly on the wall glass over here, and then only I will launch the press pull command. So I'll type PRESS, enter, then I will select this part directly on the area here, and I'll type 300 mm, which is the wall thickness. If I press escape right now and I go back to conceptual, I can see that the wall glass has been created. The metal steel or the aluminium steel of this part has been created. So what do I need to do right now is to create the glass itself. So I've already changed the UCS and park it over here. So I just need to draw another rectangle. So I type REC, enter, and I can draw it over here, directly over here, and extrude it. So I'll give an extrusion of 20. So if I go back to conceptual, you can see I've created the glass already. I can change the properties to cyan color, so we'll give the glass color of the, to differentiate the glass and the aluminium steel frames. So I'll try to move this glass over here so that it will be on the middle, directly on the center of the frame. So go back to wireframe and type M, enter, to move this particular glass. When it asks for a base point, right, try to select on the midpoint of this glass, click and move it over here and try to target to the mid of the frame. So if you go back to visual style conceptual, you can see that the glass is already inside the frame. So to make this particular glass here transparent, right, you need to select the object itself, go under layer, and you can choose a particular layer which you have set it transparent. So I have already created this particular layer, this glass layer, which I already have set it transparent. So how would you set a particular layer transparent? So you can just open up this, click over here, click layer properties to open up the layer manager. So you can see the layer manager has popped up over here. You can also type LA, enter to open the layer manager dialog box, and you can click this button if you want to create a new layer. So like this particular layer which I've already created, I have assigned it with cyan color, and I have set it, the transparency of this particular layer, to 50. So I've already made this layer transparent. So any objects which I assign it to, this layer will be visual as transparent. So how would you assign a particular object to a particular layer? You just select the object, go back to the layer properties, open up the layer list, and just choose a particular layer which you want to assign to. Click over here. So you've created one panel of this glass wall, which if you want to copy this, you can see in this design, right, there are 3 panels over here. So I'll first change the color of the frame to differentiate the steel frames with the wall structure. So I just select this particular frame, right click properties, I'll change it to yellow. So if I need 3 panels all together, so I'll just type CO, enter, and select like this. I'll choose a base point over here. Let's say here. Click it over here. Park another one. Click it over here to create all three together. So I've created all three together, and I'll type M enter to move this all three panels, and click this as my base point and put it over here like this. So I can just delete all the balance lines. Okay, so I've parked and moved this particular window glass over here. So all I need to do is to slice out the wall segment over here so that only the frames are visible. You can also use some subtraction command, okay, to establish this, or press pull command to establish this. So I'll type UCS command so that my UCS is directly on the wall. And I'll draw a rectangle directly on the frames here. So type REC enter here until here. And I'll type press pull command. But before I do that, right, I'll create a new layer first to park my window panel. So I just create a new layer here, call it layer 1, and just color it with any color that you want. Let's say red color. So I want to transfer all the window panels to that new layer. So that it doesn't interfere my wall subtraction. So just open up this and choose layer 1 and open up layer 1 and make it invisible. So change back to visual style conceptual. You can see they are no longer the window glass are no longer there. So I can just select this particular glass and move it over here. Also make the glass disable the glass also. So I can use the press pull command to actually slice out the portions which I don't want. So when I press pull this command, right, you can see it extruded the cross section together like this. So I just need to launch a subtract command by typing SU enter, click the outside wall, enter, and click all the boxes which are inside here. Okay, so I have cut out that particular portion already, and I can make the layer, the window glass layer visible again, leaving only the window panels visible. There are many ways of doing this. This is just another way of doing this. Okay, if you want to create the main entrance wall, okay, like I did over here. So you must make sure that your UCS is respective to the wall. So let's say your UCS is already here. If you want to reset it, you can click this particular button over here, change it to top view. Click this again and change it to SE isometric view. So you can see that your X, Y, and Z are already reset. So I'm going to delete this wall panel first. Okay. Okay, let's say I want to draw something over here. So I'll have to make sure my UCS is respective to this wall. So I'll type UCS, enter. Choose UCS command. Click this point. Click this projection point for my x-axis and click this point for my y-axis. So I'll change back to 2D wireframe visual style. Notice that my XYZ orientation are respective to this wall because I want to create the door entrance for this particular part over here. So I need to create a cutout or subtracted portion of this particular wall. So I'll change back to my 2D wireframe visual and I'll type REC, enter, to launch the rectangle command. So I'll try to estimate it, a starting point, let's say over here. Click, and I will call the dimension options of this rectangle command by typing D, enter, and type 1800 mm as my length and 2100 as my width or height of my door, and click a final click to define where I want my rectangle to stop. So you can see my rectangle is parked over here somewhere on the center of this wall. So I'll type PRESS to launch the press pull command. You can see the list is showing here, so I'll just click this list, this command to launch a press pull command. Click and try to find the area of this particular cutout. Click and move your mouse inside the wall so that this particular cross section is subtracting the wall. Click. You can see the cutout has been developed over here automatically. So I'll change back my visual style to conceptual, and I will try to draw the door for this particular main entrance. So you can see your UCS is now in this orientation. While resetting this UCS, you just need to click this part over here, or this button, change it to top view. Click this button again and change it to SE isometric view. And you can see your XY axis and Z axis, or your UCS, has been reset. Then you can just launch the box command, type BOX, enter, click, click, and click, just to draw the door by estimation. If you want to enter the length, width, and height of this particular box, you can just select the box and right-click Properties. You can also launch the Properties command by selecting the box and type PR, enter. Okay, or you can select the box and type MO, enter, to modify this particular box. So I'll type in the length, as in the measurement of the door. I'll type in the length, let's say I'll put 50 for my door. The width I'll put 900, and the height I'll put it as 2100. So I got my door already. You can just select the door, right click properties again, and change the color over here. Close. So you got one door over here. There are two doors over here for the main entrance. You can take a look back at this particular design over here. Right, the door is 50 mm in thickness, but it has a cutout portion over here so that we can put a glass directly on the center of the door. So you can change back the UCS so that it is respective to the door. Type UCS, enter. Click this point over here. Click this point as its X direction and click this point so that it is positioned to the Y direction. So now my X and Y are directly on the surface of my door. Change back to 2D wireframe visual style, and then you type REC, enter, to launch your rectangle command and draw the rectangle directly on the door. Okay, so by referring to this door, which I've designed over here, so it is offset around 100 mm for its frame, frame of the door. So just change back to 2D wireframe and launch the offset command by typing O, enter, and then you type 100 mm, enter, and you offset the door inside like this and press escape. So I'll launch again the press pull command to create the cutout of this particular door. So I wish to subtract the center area of this door so that I can insert the glass for this door on the center of the door. So I just click this particular command, click this part, and just push the extrusion inside so that it will create the cutout for this particular frame. Press escape. So we go back to conceptual. We can see the frame has already been created. Okay, what you need to do now is to create another rectangle for the glass. So I'll go back to 2D wireframe. Notice that the XY or the UCS command is still respective to this door. So I just type REC, enter, and draw the rectangle directly on the cutout. So I'll get this particular part over here, and then I'll extrude. Type EXT, enter, to launch the extrude command. Select this rectangle or the glass and enter 20 as its distance. So it is just a very thin box to represent the glass of the door. So I'll just go back to conceptual so that you can better visualize the glass. So just type M, enter, just to move it aside like this. So you can see the glass has been created, and you can select this particular glass and open up layer manager, open up the layer list, and assign this object to glass layer so that it is visual as transparent. Press escape. So you just need to move this glass inside into the frame of the door. So just change back to 2D wireframe to better visual inside the physical, you can, because if you use the wireframe visual, right, you can see the internal lines also, making when you move this particular glass, it will be very accurate. So I'll type enter, select this particular window, select this particular glass, enter, and choose this particular midpoint as my base point, click, and park it over here, and try to find the midpoint of the frame of this door and park it over here. So you can see when I go back to conceptual, you can see the glass of the door, right, is positioned correctly. And then I'll move this door by typing enter, select the whole door, click here as my base point, and move it here. You can type enter again, select this, choose this as my base point, and park it over here. I select this. Sorry, I should have not move the particular door. So I'll use copy command, enter, select this point as my base point, and park it over here. So I got the to draw the doors for the main entrance. Okay, let's say if you want to draw the outer frame of this particular door. Okay, let's say you want to design something like this. You can see there is a frame here looking like it is embossed, coming out from the wall structure. So while doing this, right, you really got to make sure that your UCS is directly on the surface of the wall. So I just type UCS command, click it, click this point as my origin, click any point in this projection for my X direction, and click this point to define my Y direction. Okay, so got this already. And I'll change back to 2D wireframe, right? Change this to 2D wireframe, and I'll type PL enter to launch polyline command, and I'll select this point until here, and until here. So I got the polyline projected over here, and I offset this particular polyline. Type O, enter, type 100, and offset it outside like this, and close this polyline also, so that you can use the press pull command to actually extrude for that frame part over there. So I just type PRESS and choose press pull, select this part, and I will press pull it around the extrusion height of 50, just to get the emboss effect of the main entrance. So if you need to draw the door handle, right, you can draw it by just typing cylinder command, type CY, and you can choose from the list over here and draw a cylinder. You can sorry, you can actually draw the cylinder just like this, but notice my cylinder is going this way in this orientation due to my UCS orientation which I have changed by using the UCS command previously. So in order for my cylinder to project upwards, so I need to reset my UCS. So I just select this cylinder again, and delete it. So I wish to reset back my UCS so that the X and Y axis is respective to the floor of this plan. So I just click this button over here, change back to top view. Click this button over here again, change back to SE isometric view. So you can notice that the XYZ of the UCS direction are all reset. So now I can type the cylinder command again, and the cylinder, when I draw the cylinder will project upwards like this. You can select the cylinder, right click, go under properties, and change the radius to 50 and change the height to 600, whichever dimension you wish. You can even change the color under the properties option over here. So how to move this particular cylinder or handle of this door directly on the door itself? So you can go back to top view, okay, change back to 2D wireframe, and try to move the door handle nearer to the door itself. Let's say I put it somewhere over here. Okay, and then I'll change back my view to left. Okay, so you can see the cylinder is dropped over here. So I just type M, enter, and try to move it up a little bit like this. Okay, change back to top, change back to SE isometric view, and you can view this by using conceptual. Notice that the handle is parked nearer to the frame. You can select this and just make the cylinder smaller in radius. So I'll put 30 to make the radius or the thickness of the handle smaller, and I'll type CO, enter, to launch copy command and just copy this cylinder, another set of the cylinder, to act as the door handle of the main entrance.